Good morning, students. I hope my voice is audible to you. So today in this session, I'm going to take RE, that is regular expression to finite automata conversion. Okay, the part which is regular expression to epsilon NFA conversion. Okay, which is covered in your textbook. Before get into the actual session, let us have some recall concept. Okay. Okay. You have to tell me the answer, for the first identity. What do you mean by 5 plus r, which is equal to what? 5 plus r, which is equal in the chat box. You have to type the answer. Okay. So 5 plus r, which is equal to r, regular expression only. What is the second identity? 5 with concatenation with a regular expression, which is equal to what? Yes. This is 5 only. Concatenation, which is 5 only. Okay. Next. Epsilon r, epsilon concatenation with r equal to r epsilon, which is equal. Yes, this r only. Then 5 closure. What is the result? If you are trying to make a closure of 5, I means empty language. What is the result of 4? So recall the just previous content. Identity is a regular expression. 5 closure. So anyone? Actually, the result is
5
epsilon. Okay. So after the classes are over, just go and take the content from the Google Classroom. Okay. Just check out. 5 closure means epsilon only. Okay. So what about the fifth one? Fifth one?
5.
No, epsilon only. Same epsilon. Okay. Okay. What about the sixth one?
R.
Yes. R plus R, which is R only. Okay. Take your time. Okay. No need to hurry up to get the answer. The seventh one.
R closure.
Just work out on the basis of take some example. Take one example. A closer. Okay. Take one example. A closer. What is the result? What is the result of A closer? What is the result of A closer?
Any number of A's.
Starting with what?
One name. Yes.
Starting with?
Epsilon.
Starting with epsilon. Yes. Epsilon A, like that, right? Infinite one. So here R means A closer concatenation with R. Okay. What is the result?
Same. Except
Same.
epsilon.
Except epsilon, right? Except epsilon. A. Okay. This is also infinite one. What's actually the regular expression for this language? A starting with A. Regular expression for this one. A closer means it starts with epsilon. Epsilon, all combinations of A. But in this, all combinations of A only. Okay, so except epsilon. So what is the result of this language?
A plus epsilon, the whole
Yeah,
closure.
A plus. Okay, A plus. This is the result of A plus. So what is the difference between A plus and A closer? A plus means all combinations of A except epsilon. A closer means including epsilon, all combinations of A. Okay, so this is the regular this language. Okay, A starting with A means this is A plus. So what should I write here? This is R plus. Okay, so not the important one. Next, eighth part. What is the result of eighth one?
R closure.
Okay. R closer. R closer. Okay, you can say just neglect the epsilon or R closer. Okay, so R closer. Keep as it is. R closer. Or else you can put it down R plus, right? R closer means R plus. Okay. Next here, ninth one. So I know little bit confusion one, but practice makes you always perfect. So ninth one, R closure again on closure. Ninth one, R closure only. Yes, R closure. This is this is tenth one. Already repeated one, right? So neglect the repeated one, R closure, right? Epsilon plus R closure, the same thing, R closure only. Okay. What about the 12th one? The 12th part.
P की whole closure.
P,
P whole closure.
actually P, yes, P plus Q, the whole closure. Okay, so this is the 12th one. This is the one of the gate question. Okay, but very simple one. What is the result? A or B or C or D? Just to check, take out A whether it is suitable for that automata, and take B whether it is suitable for that automata. It is the easiest way. Okay, else it is making a confused state. So if gate question mean don't think it's very tough. Okay, so don't think. So type your answer. A or B or C or D. Just one clue. Uh, just freeze out on the point of final state. Okay. On which type of transition the language goes to final state?
B.
Yes. Okay. So don't think. So always the gate question is the toughest one. So don't think. So this is the one. Okay. So final state means B closer, B closer, B closer, right? So on these type of transitions, this regular expression always goes to the final state, right? So B closer, which is presented in here only. These are all the AB combination, right? So this is the right one. Okay. Next, which means regular grammar, that is regular language, which is the subset of context-free grammar. Is true or false?
True, ma.
Yes, true. So y means regular grammar, which is type 4. Okay, which is type 4 regular grammar. Then only this is context free grammar, type 3. Okay, then next one, I think context sensitive. Then next one, recursively enumerable. Okay, so which is the subset, regular grammar, which is the subset for all the three. Okay, so this statement is true. The next one, this is also one key question. Given the language, only four, which is only three finite language, AB, comma AA, comma B, AA. Which of the following strings are coming to the L closure? So A part, B part, C part, or D part. Just take a pen and write the first answer, and based
C
on
now.
the, yes, C, C only. Okay, first A part, first I divided AB. Okay, then AA, then BAA, then AB, then AA. Yes, everything in this language only. Almost it is sorted out. The second one, starting with AA, again AA, then BAA, again AA. This is also sorted out. Okay, so everything which is in the language only. Then C part, for starting with BAA, then AA, then AB, then AA, then AA. So one B is left out, right? So this is not becoming the this L closure. Then coming to the fourth one, which is very easiest one, BAA, AA, AB, AA. This is also coming to the language closure. Okay, so except three, so everything is coming to the L closure. So 1, 2, and 4. Okay. Next to the last one, it is based on your assignment. Which is the DFA, the given automata, which is the DFA. So the language, the set of all, you have to find out the language, the set of all strings over 0, comma 1, that. So you have to find out the language from the for the given automata. It is based on your assignment only. Almost it seems like 2 3 answers are coming are equal for the automata, but actually this is, and then only it is the gate question. Only one which is the exclusive 100% suitable for this automata. Okay, Harish. Next. Yes, C only. Okay. This is only 100% suitable for this automata. Ends with 0 0. Okay. So this automata is suitable for the language ends with 0 0. Okay. Okay, that recall session is almost over. Next, coming to the actual session topic, regular expression to finite automata. So only one case we have considered here, that is regular expression to Epsilon NFA. Okay. Okay. This is the theorem. So every language defines so every language defined by a regular expression is also defined by a finite automata or automaton. Okay, so automaton, which is a singular form, automata, which is plural form. Okay, that's the difference between these two. So every language defined by a regular expression is also defined by a finite automata. Okay, so here coming to the proof, suppose L equal to L of R. Okay, this is the regular expression. L equal to L of R for a regular expression. We showed that L equal to L of E for epsilon NFA. So here the case we have taken for epsilon NFA. Okay, so regular expression to epsilon NFA. So the epsilon NFA, the E, okay, which should satisfy these conditions. Okay, the given epsilon NFA should satisfy these conditions. That is exactly one accepting state. Okay, so in your epsilon and NFA, it has exactly one accepting state and no arcs into the initial state. That is, no incoming edge to the initial state, no arcs out of the accepting states. That is, no outgoing edge from the final state. Okay, so these are the preconditions on the epsilon NFA. Okay, next the same thing. Induction proof. Okay, so induction proof means again the induction proof coming to the two part, basis part, induction part. Okay, first coming to the basis part. So three cases for the basis part. The first one, how to handle expression epsilon. Epsilon means null string. The second one, construction for phi. Okay, phi means no transition. That is empty. So here no any transition between here. Okay. Next, a sample regular expression A, a simple one, because which is basis, a simple one A. Okay, A means it moves from starting state to final state. Okay, these three are the basis. Okay, the basis for this theorem. Okay, the first one, how to handle expression epsilon. Since this is the epsilon NFA, it has the transition for epsilon. Okay, that is why it is called epsilon NFA. It has the transition for epsilon over on epsilon. Okay, next phi means no transition. So A means just it moves to one state from other state on receiving A. Okay, these three are coming to the basis concept. Next, induction part. Okay, so in induction part, again three cases. The three cases closed under for the operators are a regular expression, that is union, concatenation, then a clean closure. Okay, first one, union. So if the given regular expression, which is in the form of R plus S means, okay, this is the representation of your automata. If R plus S means here two path, okay. So the path starting with the input symbol epsilon, okay. So if R plus S means actually two path and from the starting state, okay. The first upcoming, the first part which become to the regular expression, first regular expression, and the lower part becomes the second regular expression. Yes. Okay. So again, these two cases are connecting with epsilon to the final state. Okay. So this is the automata. This is the automata for the regular expression union. That is R plus S. Okay. So this is the automata. The first case is over. Coming to the second case. Second case means concatenation. So second operator, which is concatenation. Concatenation means it's starting with the first regular expression R, then one more epsilon, then second regular expression. Okay, so concatenation means R dot S dot is negligible. So R connecting with first epsilon, then connecting with second expression. Okay, so this is the second case. Third inductive part, which is closure. Okay, so in closure means this is the automata. Okay, in closure means so from the starting state, it connects the next state with epsilon. Okay, then the actual expression, that is the closure under the closure, which is R. Okay, then one more epsilon. Okay, then again one more epsilon. Then here a backtracking. Here one backtracking transition on epsilon. Okay, so this part is over. Then in the clean closure part, a direct connection between starting state and ending state on the transition epsilon. Okay, so this is the regular automata for the regular expression closure. Okay, so once again note it down. The first basis part have three cases. The first one, how to handle epsilon. Second one, how to handle phi, construction of phi, there is no any transition. The second one is simple expression A. Okay, how to handle A. Okay. Next, induction part, the first one, the first case, which is for union. Union means from the starting state, there are two parts. Upper part means first expression, the lower part becomes second expression. Again, connecting these two parts to the final state using epsilon transition. The second one is concatenation or concatenation with S. Okay, for the first one, starting with R, then again one more transition on epsilon, then connecting with S. Okay. Next, expression for closure. Okay, this is the expression for closure. Okay, starting and ending with epsilon, in between a backtracking with closure, then a direct connection to the starting state to the final state. Okay, so this is the case for epsilon closure. Okay, this is actually your given theorem in your textbook. Okay, so this is the theorem. This is the theorem for regular expression to finite automata. In particular, regular expression to epsilon NFA. What are the preconditions on epsilon NFA in this theorem? Which means exactly one accepting state in epsilon NFA. Then no arcs into the initial state. That is no any incoming stage to the initial state. Third one, no arcs out of the accepting state. There is no any outgoing edge from the accepting state. These are the preconditions of epsilon NFA. So again, basis part having three cases. The first one epsilon, then phi, then a simple expression R. Induction part means three cases of operators on regular expression. The first one union, how to handle union, then how to handle concatenation. The third part, how to handle closure, clean closure. Okay, so the theorem is almost over. Next, coming to example. One example. Okay, so this is your given regular expression. 0 plus 1 closure 1. So again 0 plus 1. Okay, 0 plus 1 closure 1, 0 plus 1. So first I will take first case, simple one. First 0 plus 1. Okay. Right. First, I will take only 0 plus 1, not closer, only 0 plus 1. So 0 plus 1 means, which is the uh, case coming to the union. Okay, the first case of the induction part, union. So as per the rule, it has its two path from the starting state, right? From the starting state, it has these two paths. Okay, the upper one, the lower one. Okay, so the upper ones will take the part of 0. So epsilon, then 0, again one more epsilon, then here lower part for 1. So epsilon 1, again epsilon for connecting these two. Okay, 0 and 1. So this is your final state. Okay, so this is the automata for 0 plus 1. Okay, so this is the automata for 0 plus 1. So next one. So I will take the whole thing. Okay, 0 plus 1 whole closure. Okay, 0 plus 1 whole closure. So second, coming to the second automata. 0 plus 1 whole closure. Okay, so that automata starting with epsilon, right? So starting with epsilon. Okay, then 0 plus 1 whole closure part. So 0 plus 1. So this is almost 0 plus 1. Okay, this is almost 0 plus 1. Then one backtracking epsilon here. Okay, one backtracking here, one backtracking epsilon here. Then again, one more epsilon, which is added from the starting state to the final state. Okay, so given the as per the rule, so one backtracking epsilon, then one more epsilon from the starting state to the final state. Okay, the final state, at last the final state, it is connected with epsilon here. The same way, okay, here epsilon is connected to the final state. Okay, so this is part for 0 plus 1, and this is the part for 0 plus 1 for closure. Okay, okay. So almost 0 plus 1 whole closure part, which is almost over here. Okay, 0 plus 1 closure over. So next thing, take the full string. Okay, so the next one, take a whole part, 0 plus 1 closure, concatenation with 1, again concatenation with 0 plus 1. Okay, this is the part. 0 plus 1 whole closure, so 1 concatenation with 0 plus 1. Okay, so first part which is for 0 plus 1 closure. So 1 epsilon. So 0 plus 1 means two path from the state epsilon, and this is for 1 0 upper part for 0, lower part for 1. So again joined with epsilon, then one backtracking epsilon, one then one starting state to this state. Okay, so as of now this is not a final state. Okay, and once connection between this state to here, then since this is the concatenation with the next one, so one more epsilon is added. Okay, so coming to the case for expression for concatenation r, then epsilon, then s. Okay, so here r means 0 plus 1 closure. So again, epsilon with 1. Okay, so almost this part is over. Again, concatenation with 0 plus 1. So this is R part, this is S part. So this is, okay, this is R part. So one more epsilon here. Okay, so one more epsilon here. Then again coming to the S part. S part which is same 0 plus 1. Okay, 0 plus 1 means which is first induction part union. So again two part from the state starting here, epsilon here, then upper one for 0 and lower one for 1, again joined with epsilon to the final state. Okay, so this is your automata. So this is the automata for 0 plus 1 closure 1 and 0 plus 1. Okay, so I will give you time for 1 minute, just again verifying the content. Okay, just I will give you for time 1 minute. Check out the cases. This problem is also taken out from the textbook. 0 plus 1 closure 1, 0 plus 1. So first I will take 0 plus 1. Okay, so how to write 0 plus 1? Okay, just take a pen and note it out. So if you are writing the content, then only it will make a practice. Okay, so another example. Okay. Don't hesitate to write the content. So the first part, which is 0 plus 1. Okay. How to write 0 plus 1? So can anyone tell me the theorem? Okay, the whole theorem, just using few words, regular expression to finite automata. Actually, the theorem has contains a two-part basis, induction part. Can anyone explain the basis part? What are they coming for basis part? What are they coming for then induction part? I'm asking you guys. Just unmute your mic. Just explain in few words about the theorem. So, what are the preconditions on epsilon NFA? So, actually, this session is almost enough to learn the theorem.
Ma'am,
Okay, pa.
um, the three conditions are there should be exactly one accepting state and
Okay.
no arcs into the initial state and no
Mm.
arcs out of the accepting state.
Super.
And the basis has first one is how to handle the epsilon and
Okay.
construction for phi and
Okay.
simple regular expression automata
Ah,
for.
yes. Okay.
And induction step has expression for union,
Mm.
concatenation, and closure.
Okay. Super. Thank you.
Thank you.
Super. Okay. Okay. This part almost over. Next one more program, a small one. Okay. This is the program. A plus B. Okay. So A. First I will take so this is for R. So A for R, then B for S. Okay. So this is in the form of R plus S. Okay. So there are two parts. In the upper part, what do you mean by R? Which is double A. Okay. So this is almost in the form of R dot S, concatenation S. So that is why it is joined with epsilon here. Okay. So starting with the starting state. So to So two path starting with epsilon. So again A, epsilon, A. So again lower part which is exclusive of B. So epsilon, B, epsilon. Okay. So these two epsilon which is used to join the final state. Okay. So this is your final state. So a very simple automata A plus B. Okay. So kindly note down this simple automata A plus B. So one of the easiest topic in the second unit, which is regular expression to epsilon NFA conversion. Okay. So compare with your RIJ method. So compare with your state elimination method. So it is the easiest way. So anyone unmute your mic. What are the methods available for finite automata to regular expression conversion? What are all the methods available for finite automata to regular expression conversion? Finite automata to regular expression conversion. So else post your answer. One. Okay, Rakesh, the answer RIJ. Yes, okay. One of the method RIJ. RIJ state elimination method. Okay. So available methods for finite automata to regular expression conversion means RIJ method. So RIJ method, which is applicable for what? Again, type your post your answer here. RIJ method, which is applicable for what? So on this session, this part also cover. That is regular expression to finite automata over. The next session, I will take one a fresh topic. Okay. Yes, DFI to regular expression conversion. Okay, so RIJ, which is exclusive for DFI to regular expression conversion. Okay, what is the second method? State elimination method. State elimination method, which is almost applicable for all DFA, NFA, epsilon NFA. Okay, so just to recall the previous content, starting with again definition of regular expression. So can anyone unmute your mic and tell me the definition of uh, regular language? Definition of regular language. Anyone? It's a very simple definition actually. Definition of regular language, which is the first topic in the second unit. Definition of regular language. So anyone please unmute your mic and tell me the answer. Definition of regular language. Okay, at least post your answer in chat box. Good, super. Language accepted by, so the language accepted by regular expression and finite automata are referred to as regular language. Super. Okay, so two topics comes to the regular language, finite automata, regular expression. So your unit 2, which is full about regular expression. Okay, so then some few part A questions are you have already seen in the previous sessions. Okay, so let me come to the only one part. Yeah, again one more part A. Length, the language of length is at least 2. Okay, regular is write the regular expression for length. Actually, length is at least 2. Over the alphabet, sigma equal to a comma b. So in the last session, so one of the regular expression, one of the problem which is like exactly 2. Length is exactly 2, right? So the last session, I have already taught you regular expression for set of all languages whose length is exactly 2. Okay, So here at least two. So first you have to write the post your language for at least two. First, first post your answer for the language for at least two over the alphabet A, comma B. I'm asking to post the language for this at least two.
A, B, B, A, B, B.
Starting again.
Epsilon.
Uh, Not A, so AB, BA, BB. Okay, it's at least two. Then A, these are things also coming to the part. Okay, A, B, A. Okay, so at least starting with length two. So at least 2, 3, 4, 5. Okay, minimum thing is 2. 2, 3, 4, 5 length, then infinite one. So these are all accepted. Okay, so this is becoming a infinite language. Okay, so this is the example of infinite language. Okay, this is the language starting with AA, AB, BB, BA. So these are the length of 2. Then AAA, ABA, length of 3, length of 4, length of 5, length of n. All accepted. What is the regular expression? I already taught you the exactly two regular expression, which is A plus B into A plus B, right? Based on this, like, self-post your answer. Regular expression for this language. Length is at least 2, which means length 2 accepted, 3 accepted, 4 accepted. Okay, listen, A plus B whole closure, right? If you are writing the language for A plus B whole closure, it starts with epsilon, A, B, right? So, but these things should be eliminated. Since this language is accepted at least 2, so epsilon means it becoming the null, A means length of 1, B means length of 2. Okay. If you are writing the regular expression, try to write the language for the regular expression. So A plus B whole closure means it starts with epsilon, A, comma B, comma AA, AB, BA, BB, AA. Yeah, it's almost coming. But you should eliminate epsilon A, B because these are all not length 2. Okay, these are not in the case of length 2. So what I should add in the prefix part of A plus B? A plus B, the whole closure. This is also included in the regular expression output. What I should write in the prefix of A plus B, the whole closure. Shall I write A plus B? So again, A plus B. Actually, this is the regular expression for exactly 2. So at least 2 A plus B whole closure. Okay. So why I should write here double A plus B means A plus B whole closure, the language is starting with epsilon, right? For epsilon places, it's okay. For if I consider A plus B whole closure as epsilon means the languages are AA, AB, BA, BB are also included. Okay. So again here AA, AB. Okay. So totally this language is included. Okay. So note it down. This is also one of the great question. Length is at least 2. Okay. So length is exactly 2 means A plus B, A plus C. That is enough. Length is exactly 2. So length is at least 2 means A plus B and A plus B again A plus B whole closure. Okay, sir. Kindly note down this answer. So almost the session is coming to the end. Okay, so the next session, so only a fresh topic, pumping lemma. Okay, the topic name is pumping lemma. Actually, this is the topic. Okay, pumping lemma. Okay, what is the user? What do you mean by pumping lemma? What is the user? It will be a very different name, right? Okay, pumping lemma. Okay, so next session, let us see about this one. Almost the session is coming to end. Kindly note it down this answer. The regular expression for set of all languages whose length is exactly 2 means Regular expression a plus b into a plus b, that is enough. At least 2 means a plus b into a plus b, again a plus b, the whole closure. Any doubt?
Yeah, Gayatri.